The first thing first, I identify this question. Well, I need to go to rule 5 and rule 8, which is just what we have done earlier. Okay, actually rule 8 only lah. Okay, you have to identify whether is the numerator larger than denominator or the denominator larger than numerator. Okay, so first thing first, you have to identify rule 8. Okay, in this case, the numerator is larger than the denominator. For the zeros is larger than poles, right? This A, this is B. A is larger than B. So in this case, what did we do? If you remember, in this case, then the zeros should be circled, so that there may be some 2 poles over here, and then my pen again. Okay, 2 poles will meet each other, and then one goes to one like that, go to the zeros, and another one goes to infinity. So this is the case, if you remember, right? So therefore, if this set, then you understand that the root locus, you should be able to understand how the root locus will be. So the next thing we need to do is to identify how many zeros and poles are there. Okay, ID, poles, and zeros. And therefore, as you can see, we have one zero, which is -2. We have 1 zeros, which is -2, and then we have 2 poles. Okay, so when you take out this question, make sure you know that what makes the denominator equals to 0. Okay, if you see some s outside the thing, don't multiply inside, because if this s is equals to 0, whole thing becomes 0. If you multiply inside is s squared plus s, you don't know which is which already, right? So you have 2 poles and zeros, it cannot be somewhat. So in this case, you just leave it like that, and then this one becomes 0, whole equation becomes 0. And then now we talk about this. So if s is equals to -1, this whole equation becomes 0 also. So therefore you have 2 poles, which is one at 0 and another one is -1, right? So the third step you need to do is to plot poles and zeros to visualize. So you can see that the zeros is at -2, and the one pole is at 0, and another pole at -1. Right, so this is our what we can deduce from it. So next thing is talk about rule 4. So as you can go back to our slide, we first tackled this rule 5 and rule 8, okay, which is in your video on this part. The next part is to tackle 3, 4, and 7. Okay, in this case, rule 3 states that whatever thing that is on the open loop singularity, poles on zeros, to the right are not on the root locus. Okay, this is wrong. Are not on the root locus. So in this case, to the right shouldn't be not of the odd number singularity. This is 1, this is 2, this is 3, right? Odd, this is, we just name 1, 2, 3 lah, okay, in this manner. So therefore, the odd numbers here is 1. I'm just naming this as number 1, number 2, number 3. So this is one singularity, this is one singularity, this is one singularity. So these are odd numbers, singularities. And therefore, to the right shouldn't be in the locus. Okay, to the right shouldn't be in the locus. Then you may wonder why that's so. Okay, every time poles move to 0 ma. But if you remember, now you are talking about the numerator is larger than the denominator, is the rule 8 comes in. Okay, so in this case, it has to go, one pole go to 0 and another pole goes to infinity. Goes to infinity. So you should be able to understand how it is being plotted. And then, next step, determine number of asymptotes. Do we have any asymptotes? So you just check it out. Okay, so what you're gonna do is actually to see, okay, This is rule 4. Okay, this is the center of gravity, sum of the real poles minus sum of the real zeros. So in this case, the real poles are what? So the poles are actually 0 and minus 1. So if you sum it up, it will be 0 plus minus 1. And then, okay, what is it? Minus sum of the zeros. So in this case, the 0 is minus 2 only, right? So therefore, it's minus 2. So this is simply saying that all the poles, if you sum out, and then minus away all the poles for the zeros. So in our case, all our poles is only, we have 0 and minus 1. If you sum it up, it's over here. And the poles we only have 1, so if you sum it up, you still only have one poles, or one zeros over here. And then divided by n minus n, which is, so therefore is minus 1 plus 2. And then n minus n is actually 1. Okay, n minus n is actually 1. So therefore you get 1. So the asymptote is at 1. In this case, hold on. Let me repeat again, this is the center of the asymptote. We don't know whether do we have or not now. So as you can see, this is the center of the asymptotes. So now we have to find the number of asymptotes. Okay. So just repeat again, this is finding center of asymptote. I may say wrongly just now. So now we have to find the number of asymptote. This is the center asymptote, this is the number of asymptote. So in this case, you see n minus 1, right? So in this case, n minus n is actually 1, right? N minus 1 is 0. So therefore, there's only, if let's say if you require from this equation 0, this means that there is no asymptote at all. Okay, this means that there's no asymptotes. If there's, let's say 1, let's say if you have 2 minus 1, you have equals to 1. This means that you have two asymptotes from 0 and 1. Okay, and then you sub it into this Q. Okay, this is the K, right? And then, yeah, I believe you get what I mean. So the first angle will be 180 degrees minus divided by m minus n plus 0 times this whole thing. This is the first angle. And then if the second angle will be 180 degrees divided by this one plus 1 times 360, because this is 0 and this is 1. If you have 2, then you have to multiply with the 2. So this k is take note that it's different from this k. Okay, this k is just a constant k, some integer. So you have in the test you have to state that this k is some integer k. Okay, and then also this k also, this some integer k is not the controller k. You have 1 mark. Okay, so it's very crucial you have to state that. And then yeah, so we identify that there is no asymptotes, okay, from this. So we can move on. So we have already cleared away rule 4. We have cleared 8, 3 and 4. And 7 is simply saying the double points. Okay, since you have double points, what you're gonna do is actually to use the open loop transfer function, and then you integrate one time. Differentiate one time. So it is g of s over d of s. So excluding the k, so you'll be like s equals to s plus 2, s plus 1, and then you have to differentiate it lah. So you'll be something like 2s plus 1, s plus 2 is a quotient rule lah, okay? And then minus away blah blah blah. Okay, I'm not gonna go through it, but you should get the result. So whatever thing at the numerator will make the whole equation 0, right? Alright, whatever 0 divided by anything should be 0. So g of s divided by d of s, you remember, root 8 is equals to 0. So this is the case. So if you do that, you'll get, after you do finish the thing, you eventually get a quadratic equation, and then you solve the quadratic equation, you can eventually get the double point. Okay. So in this case, I did out the MATLAB. So the double point should be at this point over here. Okay. And then we have cleared away these two parts. Rule 5 is simply saying um, pretty much not much lah, okay. And then rule 1 and rule 6 is the angle criterion. And then rule 1 and rule 2, rule 1, rule 2 and rule 6 are just an angle criterion. So I'll just give you a few of the answer. Not answers, but rather and some few of the angle criterion. As you remember, the open loop zeros, okay, is the angle of arrival, right? So one pole will actually arrive here at 30 degrees. So this is what it means. And this is calculated through the, when, let's say you have an angle over here, what is the angle from here? What is the angle from here to here? Plus what's the angle from here to here? Plus what is the angle from here to here? And plus what the angle from here to here? And then you sum it up. It should be equals to minus 180 degrees. And then you find theta. So this is something I didn't know, so maybe you can take note. And then you go and practice. So you should go and practice all this tutorial. So I'm just giving you a very brief concept on applying the simple rule, okay, throughout. And then this should do the trick for. And then if if they ask you find what is the value of k if you are given a certain s value, then you should go to my rule 2, and then some angles you can go to rule 1 due to the angle deduction and etc. So far we have talked all about the Blue Lotus. So I hope that I can give you a good understanding. So next lesson, okay, this lesson is 3 and 4, so 2 lessons combined. And then next lesson I'll just do 5 and 6 in terms of Nyquist plot, which is also something. So I'll see you there.